Hey, what's going on, guys? We're going to take a look at the Windows 95 product key generator, the OEM product key generator. I do want to convert this all to Rust code and start working primarily on Rust, just because I like the language and it's kind of similar in a lot of ways, but it's just refined. It's a completed language, and it has a lot more documentation, a lot more resources, and a lot more packages or crates, whatever you want to call them. So we will come back to V and intermittently practice with V, but it just isn't finished yet, so there's not a big push to really learn too much about it. The other thing we are going to do is probably use the cursive library, which is ncursive bindings, in Rust to generate a GUI and kind of pretty this up, make it kind of more presentable as an application and not so much just a little terminal hack. So hopefully that'll be something for the future, but let's go ahead and run through this, make sure we understand it, and we'll go from there, make our lives a lot easier. So for the first section, this is just going to be explaining the key itself. The first 3 digits of the product key, they are indicated by the X's. This is going to be a 3-digit Julian date, so just the number 1 through 365. If it's a number that's less than 3 digits, it is padded on the left side with zeros. So if you get 95, the end result's 095, and so on. For Y, this is going to be the right 2 digits of a number between 95 and 103, and this is meant to resemble a year, so between 1995 and 2003. But of course, if it is a 2-digit number, a 3-digit number, we do pop off that first digit to get just the last 2. For the next part, the OEM, it is always the same. For the OEM install, it's always going to be OEM. You can't change that. It's going to be fixed in place for you, so nothing to worry about there. The ends, there's 7 of them. The first 2 digits are always 0, and the remaining 5, the qualification is when added together or summed together. When divided by 0, it must have a remainder of, or when divided by 7, must have a remainder of 0. So let's say we have all 1s somehow. You would add all 5 of those 1s. The sum is 5. If we divide that by 7, it's not a perfect 0. So that would fail. That would not be a valid key. However, if we had the numbers 1, 1, 1, 1, and then 3, we know that 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 3 is 5, 6, 7, divided by 7 is 0. That would be a valid key, or a valid key segment, so we'd continue. So that's how that works. If we don't get a number that works, we just reevaluate the random number and try again. And the last one is, again, super simple as the first. It's just a random number, and this is just going to be a 5-digit number in this case. Okay. And jumping right into segments, it is a struct, a template essentially for us. We just have all of our components here, just represented by the lowercase version of what we see up here. And jumping into main, we're going to go ahead and declare S and set it equal to a new instance of segment. And for each component, we're just setting them equal to the function call of the same name. So we've created a function for each. We're evaluating and returning. And then everything after the exclamation point, this is just formatting. So again, in the first one, it's 3 long, but it's possible you get a 2-digit or 1-digit long number. We just want to pad up to 3 digits on the left with a 0. And you'll see that as you output it. Say, for example, we had 95, it would be 095, not just 95. Same thing down here, squish these together because they're all one segment, and then after that, everything with a hyphen, as you'd expect. Let's go ahead and evaluate this first one, though. So all we're doing is getting a number 0 to 366. I'm assuming it's exclusive generation, although I don't know. So in the case you see you have a 000 or a 366 on your screen, when you're running this, that'll be fixed. When it's converted to Rust, we'll make sure if it is inclusive, we don't allow for the 0 or the 366 to be generated. But I'm not sure. I totally forgot to actually look that up beforehand. So there's a possibility this is incorrect. I'm really not sure. But either way, the keys will still generate. If you get one that's wrong, just go again. Here's Y. So Y is the one that's a little bit weird. We'll go over it quick, and then we'll do the math on it briefly. So for Y, we start with a raw segment. It's just going to be a random number, again, between that range we saw above. And then we have an empty array called array segment, and this is going to hold the array representation of our integer here. So if we have integer 103 being generated here, we're going to have an array with the 0 slot being 1, the first slot being 0, and the second slot being 3. And the reverse segment, that's just going to be the array that's reversed, and that's because the way we pop these off to do the math on them down here takes the last one first, and and goes from back to front rather than front to back. So we need to reverse it to get the correct number, and you'll see that later. So we have our raw segment. If it's greater than 0, we're going to set that digits equal to the remainder of that raw segment divided by 10. and then set the raw segment now equal to the actual result of raw segment divided by 10, not the remainder. And then from there, we just insert that digit or pipe it into array segment, and we would be all set there. We'd complete that until this is not true, and then that would be done. Now remember, we do have to have it 2 digits long for the second portion. So if we get a number again like 103, want to delete the last one before the reversal, because that would be the first, and then we can reverse it. So let's say we had 103, we pipe everything out, gets converted to 301. We want to delete the 1, reverse it, and we get 03 for 2003. That's how that would work. And we will do just a quick example because this doesn't make a lot of sense out of context. So let's go ahead and pull up a calculator, and we'll show this in action here just briefly. We'll clear this out. Let me make that viewable for you. Perfect. Okay. So to start off, let's just assume we have our raw segment equal to 103. For whatever reason we roll, we get 103. If we pull up the calculator and we do our first step, which is going to be modulus 10 to get the remainder, we're going to do 103 divide by 10. It's going to give us 3 right after this decimal. So there's our first remainder, would be 3 in the 0 index. And now you can see, of course, raw segment now is going to be equal to this whole result, 10.3. And we can now go ahead and divide again. Divide by 10, get our remainder of 0. There we go. And you can see here, I apologize for that. And you can see here that we're basically, all we're doing is taking the full integer here, and imagine that's a 0 and a decimal. We're just picking up this decimal and putting it over just 1 each time we divide. So we can go again, put 1 here, that would be 100, and then 1000, of course, would be right there. So we're just picking up every time we divide by 10 and placing those zeros 1 over to the left each time. So if that makes any sense to you there. And you'll see that here as we get to this last one. We'll pull back up the calculator and divide it by 10. Oops. I'll do 1.03 divided by 10, and we get 0.1. So there's our last one is a 1. And then, of course, in this case, we wouldn't evaluate to true. We'd do another 10. And, oops, I went one further, but you get it. It would now no longer be true, so we'd stop there at 301. We delete that last one. Let's go ahead and get rid of that, and then reverse it. So it'd be 0, 3. And that's how we'd end up with those results. So that's how this works. A little bit weird. But yeah, you can definitely get through that. If you can figure the y out, the rest will be easy for you. And this is n. This one's a little bit weird for this. I have 2 functions here, int to array and array to int, which is right here, which is actually what we use to get that reverse segment back to an integer. These are just transcoded from C++. I just translated rather. So I just took C++ code that I knew worked and I made it into V code. Really not anything you can avoid for lower level languages. A lot of the times you'll have to make silly methods like this or functions, but I don't want to get too deep into it because for most languages it's going to be part of the environment anyway, so it's not a big deal. It'll already be built in somewhere. You normally won't need this. So the descriptions are here. You can look up the formulas yourself, re-implement them if you want to make them more efficient or better, but this is just pasta that I copied in after like asking OpenAI to give me a C++ example or something. But yeah. Let's see. For segment n, first thing first, we're going to get a random number again, 5 digits in length, and then create an array based off that. So just inserting all of these again, just like before, into an array. Set the sum equal to 8, and there's a reason for that. And then we have an iterator commented out because we're not debugging, but I was entering a number to count how many times I tried. Forget about these though. So coming right here, because we have the sum equal to 8, 8 modulus 7 does not give a remainder of 0, so this would actually proceed to set the sum to 0, get a random integer from that span, convert it to an array, and then add all of them up. So for each element in the array of the integer, sum them all up. And if, again, we come back here and it's true, it's just going to go ahead and return it. So we're good. If it's not true, we end up here again, we regenerate, and we try again. So that's how this loop starts. That's why he was seeing 8 here, just to ensure we start it. And yeah, not bad. We can go ahead and take this off now. The calculator's in the way. Other than that, if you are on... Oh, no, Z, we forgot Z. Z is just, again, going to be 5-digit number. We're just generating it and padding it with zeros if it's lower than 5 digits. So super simple. We're combining all those, throwing them right in here, and that's what gives us that final result. Can we run this? Yeah, we can too. So here's like a product key. You can see we had 333 would be the Julian date, 2002 would be our year. There's OEM. We have 00, and then 3 plus 3 is 6, plus 1 is 7, and then that divided by 7 is 0, so that would be valid, and there's our random set. So, yep, that's the walkthrough of that. We can get this out of the way. I'll get those links updated, and the next time we do something, it'll be in Rust. Hope you guys enjoyed that. Have a good one.